Welcome back to User Upload, where we take a hands-on approach to ethical hacking and security engineering through CTF challenges and real-world simulations. In this lab, we're going to take a look at new products in early development that have been placed on an internal network for testing and debugging. This is normally done by developers to ensure that any potential security risks are confined and can only be accessed by trusted internal machines. In theory, it's a secure coding practice, but it's based on the hypothesis that the internal network is uncompromised. If a machine that has access to the internal network gets compromised, it's possible to access these instances using tunneling, specifically, in this case, SSH and FTP. We're also going to utilize Hydra to run a password cracking username attack, and we're also going to check out PostgreSQL, the database, and we're going to use that to enumerate some more on the machine and reveal the flags. Getting started with the lab, we launched the virtual machine provided to us, and we begin enumerating the IP address as well. We find two open ports, port 21 running VSFTPD 3.0.3 and port 22 running OpenSSH. Port 22, or SSH, is designed to upload, download, and transfer files from one location to another in computing systems, and we're going to take advantage of that today. Users could connect to FTP servers anonymously if the server is configured to allow it, which in this case we can see that it is. Let's get started with connecting to the server and enumerating the directories. Here we connect to the FTP server by typing in FTP followed by the IP address. This is b10.129.78.63. As you can see, we begin to get connected. It's asking us for a name. We'll type in anonymous. Please specify the password. We're just going to type enter here. As you can see, it says login successful. Remote system type is Unix, using binary mode to transfer files. What we're going to do here is type in dir, and that's going to actually list the contents of the directory. You can use ls as well. And we have a mail backup directory. Going to cd or change directories into mail backup. We're going to cd and change directories into mail backup. Here we're able to see two different files, a password policy.pdf and a welcome.txt. Let's go ahead and cat the password policy. If you try to cat the password file, if you try to cat the password policy.pdf, it will not work. We're actually going to have to download the files to our machine, and then we will open them. We'll be doing this with the get command followed by the file name. Here we've downloaded the file to our machine. We'll download the other one as well. It's always good to get as much information about the target as possible. We ls on our machine, and we see the password policy.pdf. We will cat that. You can see a bunch of binary here. But we do get a hash file here. After downloading the passwordpolicy.pdf to our machine, we're going to grab the welcome file as well. We're going to cat that. Here we can see the message provided to us. Hello everyone, we would like to welcome you to our team. We think you'll be a great asset to the funnel team and want to make sure you get settled in as soon as possible. We have set up your accounts that you will need in order to access our internal infrastructure. Please read the attached password policy with extreme care. All the steps mentioned there should be completed as soon as possible. If you have any questions or concerns, feel free to reach out directly to your manager. See some key information about who this file was addressed to. Here we have a couple of email addresses: optimus@funnel.htb, Albert, Andreas, Christine, Maria. Subject: welcome to the team. Open the password policy file. Let's go ahead and open the password policy file. Open password policy.pdf. So launch this. Let's take a look here. Passwords are a key part of cybersecurity strategy. The purpose of this policy is to make sure all resources and data receive adequate password protection. It's going to go ahead and lay out some basic guidelines for the employees here. In addition, employees should be also use common sense in choosing passwords. La-di-da. Passwords should be unique. Blah, blah, blah. Default passwords. Blah, blah, blah. Document goes on to explain best password policies for new hires within the organization. And within this PDF that's supposed to be addressing the cybersecurity needs of the organization, we're able to see the here about how these accounts were set up and how we're going to move forward with hacking into the system. The bottom here says, for example, the default password of the funnel 123 must be changed immediately on login, which means we're going to use these email addresses that we got from the text file. We're going to log in. We'll grab all our usernames and email addresses. Go ahead and paste that in a separate document if you'd like. We'll also grab the root email. Try that as well. So we're going to go ahead and save that to usernames.txt file that we just created. We'll move it to the desktop. And we'll start opening Hydra. Start with Hydra-L. We'll input the username.txt file we just created. We'll do this instead of inputting each command or each username and password manually. This will avoid locking us out. Here we can see the note as well for the Hydra command. We'll run the Hydra command and get the password. We SSH in and list the system here. After this, we can pretty much enumerate and have full access as Christine on this machine. However, we're going to take a look at the sockets for any potential active listening sockets. I'm going to go ahead and use ss-tln to list and display active TCP sockets. The one we want to take a look at specifically here is column 4 with the IP 127.0.0.1, which identifies local host. Essentially means it can't be accessed from outside the network. And it's using port 5432, which is PostgreSQL or SQL. So we're going to need to enumerate more, and we're going to need to use the active ports. At this point, we're going to take Christine's credentials and the socket statistics and the fact that they're using port forwarding, and we're going to go ahead and use that against them. What we're going to do is basically set up port forwarding so that we can route the SSH traffic from our server to the PostgreSQL server, or the port 5432 in this case. We'll go ahead and do that with SSH-L followed by the remote server name. We'll go ahead and do that by typing in SSH-L for listening. So we'll specify the port. So here we can see the command that we use to start port forwarding. SSH-L, we specify the port 1234. Localhost, which is 5432, or the PostgreSQL database in this case, followed by the user and the IP. Entering Christine's password, we can see that we have a shell on the target system once again. However, it's under the hood of SSH, which is opened up on the socket port of 1234. So now that that traffic is being forwarded to 5432, or the PostgreSQL database, we can log in with SSH again and establish a different shell. Here's a quick depiction of the new port that's listening under 1234. And we will also need to install PSQL. As a side note, we may elect to just establish a tunnel on the target without actually opening a full-on shell on the target system. To do so, we can use -F and N tags, which send the command to the shell's background right before executing it remotely. And B tells SSH not to execute any commands remotely. From here on out, we are going to SSH into the machine. However, we're going to do it from our new port of 1234, connecting to 5432. This is going to launch the PostgreSQL database. Here we can see the PSQL, -U for username, Christine, the -H for localhost, and P for port 1234. Below we can see some names in the database: Christine, Postgres, secrets, and template 0. Using the -C command, short for connect, we can connect or select a database and interact with the tables. We'll go ahead and do that now. We're going to connect to the database of secrets. We go ahead and connect, and we use /DT. All right, so we get on the machine, we get in the database. We'll use -DT to dump the contents of the file. We'll select from flag, and this will reveal the root flag for the lab. We'll continue on answering the questions, but this has been pwned. Which service is running on TCP port 5432 and listens on the local host? We'll grab the flag, copy it, we'll paste it, and funnel has been pwned. Thank you for watching the video. Like, subscribe, and comment for more.